Hi everyone, welcome back to Dave's Math channel. I'm your host David Tare, and this is my continuing feature on the Math Lovers book. And as I do every Saturday, today I'm featuring another biography of a famous mathematician, and today's a really big one. It's Galileo Galilei was his full name. Here's a picture of him. He lived from 1564 to 1642. He's been called the father of modern science. At least one of the greatest scientists that ever lived. Also a great mathematician. I mean, he applied a lot of very important math to his scientific theories. And as a matter of fact, I would say that's kind of what made it modern science versus the more medieval theology, or even the stuff that the ancients were calling natural philosophy at that time, like Aristotle. He didn't use any math in any of his theories, but Galileo did, and he made very important, he performed experiments to back up his theories. So I think that's the main way he stood out. And he did an amazing amount of work. I mean, he's one of my heroes in terms of science. But I'm just going to talk about what he did. He did a lot of stuff. And I think his first big discovery was actually when he was just 17 years old. He discovered the principle of the pendulum. And the way he did, he was with his family, I guess, at this big church. And I believe this is the church where he was. I'm sure they remodeled a lot of it since 16th century. But, he was bored, I guess, in church. I don't think he was very religious, unlike most of his peers, probably his family too. But there was an earthquake during the sermon or whatever it was he was listening to. And the chandelier shown in the middle here started shaking right after the earthquake. It started shaking pretty violently, I guess. And what he did, being the kind of having the scientific mind he had, he decided to try to time the period of the chandelier. In other words, the time interval between each time it swung back and forth. And he did it since there were no watches at that time. There were no accurate timepieces, especially portable ones. The way he measured its period was with his pulse. So I think that's the way he measured all of his timing, actually. Because the pulse is pretty regular most of the time. So he counted how many heartbeats, went on during each swing. And what he found, to his surprise, is after a long period of time, the amplitude of the swinging got a lot less because of friction, because it doesn't keep swinging as violently as it does at first. And as the amplitude was going down, he noticed that the period stayed the same, roughly. At least I think as far as he could tell with his pulse. So he basically discovered the principle of the pendulum when he was 17 years old, by timing the period of the chandelier in his church. Pretty amazing. And I think it was Christian Huygens, almost a century later, that built the first pendulum clock. And for the next, I think from the 17th century until the early 20th century, those were the most accurate clocks in the world. So, and thanks and to a big part to Galileo for discovering the principle of the pendulum. So I think that was a pretty great discovery, and I don't think most people even know about this. But what else did he do? I think that one thing he is much more well known for was discovering the law of falling bodies. And I don't know if this is true. I heard this is an apocryphal tale. But the story is that what he did was, he determined that heavy objects fall at the same rate as light objects, at least in the absence of wind resistance. And supposedly the way he did this was he went up to the top of the Tower of Pisa and he dropped two stones of, different size, one big one small one. And the prevailing dogma of the day was that heavier objects fell faster than light objects in proportion to their weight. I think that was one thing that Aristotle had said, almost 2,000 years earlier, and the church promoted this dogma. But Galileo supposedly determined that was false by dropping these two stones off the Tower of Pisa and seeing that they fell, that they basically fell at the same speed. Maybe the light went a little bit slower because, I don't know if it'd be slower or faster, probably a little bit slower because more wind resistance proportional to weight, but basically the same speed. I don't think he really did this experiment. I know that another way he determined this was by rolling, objects, balls probably down an inclined plane and seeing that they rolled at roughly the same rate. And not only did he discover that, objects fall the same speed, regardless of their weight, but he also discovered that when you drop something, it's not a constant speed, it's a constant acceleration. Again, in the absence of wind resistance. And he came up with this mathematical law describing it, the law of falling bodies. There's actually two ways you can write it. You can write V equals, usually people write G. Here they're writing A, but little g is known as the, gravitational, the acceleration due to gravity at the surface of the Earth is approximately 9.8 meters per second squared. And that's one way you can write this law. V equals gt, where t is the time since you dropped the object. Another way, you can also talk about how far it falls as a function of time. And that turns out you could actually do calculus to derive the formula on the right in terms of the formula left. X, people usually write y or z, but the distance it falls is here they write at squared over 2. It's more customary to write gt squared over 2. So that'll tell you how far the object's fallen as a function of time. And like I said, it's not a constant speed, it's a constant acceleration. That's another thing Galileo discovered. And that's actually due to Newton's first law. He kind of discovered Newton's first law, too. But I'm not going to get into that. And I think one thing probably the thing he's best known for was he didn't invent the telescope, but he made his own telescope, which was the most powerful telescope built at the time. I think it was something like 30x. It was powerful enough for him to make these really, really amazing astronomical discoveries. I don't know who invented the first telescope. I think it was only maybe a year before Galileo. I think the first telescope I think was built in 1608. And I think it had 10 power, but Galileo's was 3 times more powerful. And I think he built it the following year, 1609. And one of the first things he did with it, which I'm not even sure if the inventor of the telescope thought of doing, was he made nighttime observations of the heavenly bodies. He made some amazing astronomical discovery. He basically revolutionized astronomy with his observations, and I'm just going to talk about some of them. I think one thing he's really known for is he discovered these 4 moons of Jupiter. They're now called the Galilean satellites. I think now there's over 100 known satellites of Jupiter, but he discovered the first 4, the biggest ones: Io, Europa, Ganymede, and Callisto. I think they're shown roughly to scale on this picture, but not to scale with Jupiter. Jupiter is much, much bigger than shown in this picture. Here's the pictures. These are actual photos of the Galilean satellites, and I think this is to scale. So, yeah. So anyway, Ganymede's the biggest of them. I think Ganymede and Callisto are actually bigger than our own moon. There aren't too many moons in the solar system that are bigger than the Earth's moons, but Jupiter has a couple of them. I think Saturn has 1 or 2, and Neptune. I think it was only maybe 5 or 6 moons in the solar system that are bigger than our moon, but Galileo discovered a couple of them. And this was a very revolutionary discovery because, part of the dogma, there were kind of 2 pieces of scientific dogma that were prevailing, at this time, early 17th century. One of them was Aristotle's natural philosophy, which said that, objects fall at a constant speed and the heavier objects fall faster than light objects, which Galileo showed was not true. The other thing he showed either with Ptolemy. Ptolemy, he was a 1st century Roman astronomer. He wrote this book called the Almagest, which kind of became the dogma of astronomy, for almost 2,000 years. It was a geocentric model, which said that the Earth was the center of the universe and all the planets and all the stars revolved around it, and the sun. But Galileo actually proved that the sun was the center. I think Copernicus first suggested it. Yeah, I'll get to this later. But he proved that the sun was the center of the solar system and not the Earth. And he, another way he did that was he looked at he looked at the phases of Mercury and Venus and saw they had phases. They wouldn't have phases if the sun was the center, but he discovered their phases and basically proved that the sun was the center of the solar system. The Earth went around the sun and not the other way around. And the church got so upset at him for this that they put him on trial, and ultimately he was convicted by the church. And his punishment was house arrest. He spent the last 9 years of his life from 1633 to 1642 basically imprisoned in his own home. He wasn't allowed to leave his home, and all his teachings got banned by the church. And he was also forced to recant his theory. He was forced to publicly, admit that he was wrong and that the church was right. Pretty horrible. I think it was a really, really horrible mistreatment by the church. And it's not the only time something like that's happened. But it's one of the most well-known. And I think I just want to say one more thing about this before I get off of it. Most people don't realize this, but I learned this a long time ago. The church didn't even apologize. The Catholic Church, they were the ones who convicted Galileo. They did not apologize for the conviction of Galileo until 1969, which was the same year we went to the moon. I guess by then they couldn't deny that Galileo was right, or at least they couldn't, teach the dogma of Aristotle, of Ptolemy anymore. I mean, there were pictures from space of the Earth, and we'd gone to the moon, and there was just way, way too much evidence by then that Galileo was right. But it was a really, really horrible misjustice. It still makes me upset. And there's stuff like this that happens today too. We're not done with dogma. We're not done with authoritarianism, unfortunately, and Galileo was a terrible victim of that. But ultimately, his theory did survive, even though his life ended badly. There were other scientists who verified his theory and vindicated him, essentially. And anyway, I guess that concludes my video for today on Galileo. So thank you for watching. Long live math, and I'll see you guys next time. Bye.